Hi everyone, my name is Mohammad Khajuriwala. I'm a solutions architect. Welcome to my channel, Cloud Buddy. This is my first video. I'm really excited to record this one. On this channel, I plan to talk about the different serverless offerings by cloud providers, how they can be used in different design patterns, and how it can be used in a cost-effective and secured way. In this video, I'll talk about how Apache Beam pipelines can be orchestrated with GCP workflows. So this would be the agenda for today. First, I'll start with what Apache Beam pipelines are. Next, I'll talk about GCP workflows. Then I'll talk a little about the use case that I'll be using for today, which is real-time order and shipping analytics. I'll finally jump into the demo and a little bit about the costing to implement this design. What is Apache Beam? Apache Beam is a unified programming model which can be used to process data in batch or streaming mode. So if you have large scale data that you want to process in parallel or you have an ETL job, Apache Beam can be a really good choice for that. Um, it's flexible in terms of programming languages and execution runtimes. So if you are familiar with programming languages like Java, Python, you can use those to build your Apache Beam pipelines. And you can use any of the execution runtimes, like if you're on GCP, you can use Dataflow, or if you're working on any other cloud provider, you can use Flink, Spark, Direct Runner. Any of these can be used. Direct Runner is the one that you can use if you want to test your pipeline locally on your local machine. So in use cases like you want to do data enrichment or machine learning, or you want to transfer data from a particular file to a downstream API, in parallel, you have petabytes or terabytes of data that you want to process. In all those kind of scenarios, Apache Beam is a really good option. Now, moving on to the next slide, what is GCP Workflows? GCP Workflows is a serverless offering by the Google Cloud Platform, which can be used to define tasks in a particular sequence, or you have a number of microservices that you want to call in a particular defined sequential order, or you have certain tasks that you want to do. So GCP Workflows can be leveraged to do that in a particular sequence. It takes care of any retries that you need to do due to some failures. And it also shows you how your particular workflow is progressing. So it's a really nice offering. If you're familiar with the AWS cloud step functions, so this can be very similar to that. Now, the use case where this design can be used, imagine you have an e-commerce website where the user logs in and purchases some product. He adds it to the cart and finally the shipping takes place. Now, this is all that the user sees, but in the back end, you always want to look at the analytics. What user is coming in, from which region he is, what kind of products is the user buying, how many products is the user buying. So that is where we can use Apache Beam pipelines. Um, you can have two pipelines, one which is capturing the details of the order that the user makes, and the other one would be the shipping details. And in the backend, you can generate an entire dashboard of information which can help you to drive more business. So this is the scenario that I'll be talking about, and I'll be showing a demo where I'm using two streaming data flow pipelines, one for the one to capture the order details and the other one to capture the shipping details. And since we want to capture this in real time and we want to make sure that the dashboard is always updated with real time information, we'll be using GCP workflows to make sure that the Apache Beam pipelines are always up and running. Okay, so now it's time for demo. But Before we get into that, I just want to highlight that, I have also written a blog on Medium on the same topic. It's called Orchestrating and Choreographing E-commerce Order and Shipping Analytics with Apache Beam and Google Cloud Workflows. So you can also go to this blog and you can check out the details regarding this particular topic. If you want the links to the GitHub repositories where I have published the Apache Beam Pipelines and the GCP workflow, uh, the GCP workflow input parameters. You can find all those details through this blog. I'll put the link in the description below. Moving on, the architecture that we'll be looking into today is somewhat like this. We'll be having two data flow pipelines. One is order analytics and the other one is shipping analytics. Both will be listening to a pub subtopic. So any message that is published on this topic will be consumed by the data flow pipelines and it will create an entry into the BigQuery table. So the code for the Apache Beam pipelines is pretty simple, straightforward, nothing complex that we are doing here. But in a real world scenario, we won't be having such pipelines. There is another method to do this, which is we can create a subscription into the pub subtopic, which directly pushes the messages into a BigQuery table. I have written a blog on that as well. Maybe you can check that out. I can put the link into the description below. Now the highlight of this particular design is the GCP workflow, which takes care of orchestrating the data flow pipelines. So basically, if your data flow pipeline doesn't execute as expected, if it fails, or the region that you're trying to deploy your data flow pipeline in doesn't have the capacity to create a job at that moment, GCP Workflows will make sure that it keeps trying to create that particular job. You can control this with a parameter. So you can have a parameter which says that you just want to try a finite number of times, let's say 5 number of times, and then it will stop. So if you have a streaming job and you want to make sure that it keeps running at any moment, and if it fails you want to create a new job, GCP Workflows can be a really good service which can help to do that. Let's go ahead and see how the GCP workflow looks like. So this is the workflow. Basically, we have two parallel branches, one to monitor and create the job for the order data flow, and the other one is for the shipping. Now the code in both these branches is just the same. It's the only difference is the parameters that it requires to create that particular job. So if we look at one of these, the order branch looks like this. First, it will go and create that particular job, and then it will keep monitoring whether that job is running or not. So you can tweak this in a way that you want. Now, the way that you can do this is by monitoring the data flow job for one of these statuses. If the data flow job status has changed to failed, cancelled, updated, or drained, that means that your data flow job is not running anymore. And in that case, we exit out of this particular step. We go down and we reassign the value of creating the new job again, and the workflow takes care of creating a new data flow job for the order pipeline. So the idea is to keep monitoring for that data flow job, and if in case anything goes wrong, create a new job. Now if you look at the launch order data flow, now all these are sub workflows. We have created one workflow and all these are sub workflows. So this makes it pretty easy in terms of maintaining it and readability. So this is something that I would recommend you do if you're using GCP Workflows. Now, as part of this particular workflow, you're just launching a new job, and if the new job is created, it goes to the next step. If you look at this particular sub workflow, out here we are monitoring for the status, and if the status is running, we sleep for 30 seconds and we go and we check again. We check the status again. If it has failed or if it's part of any of those statuses like drained or cancelled or any of those, we exit and we move to the next step, in which we just reassign the value for the retry count and we go and create a new job if the retry count has not exceeded the maximum number of retries. So yeah, pretty much it. This is the way the GCP workflow looks. And like I said, the data flow is quite simple. It just reads the messages from the pub subtopic and creates a new entry into the BigQuery table. So let's see this in action now. We just give this particular JSON to the workflow, which says that, you want to deploy the workflow, the parameters for it, like the project, the maximum number of retries, which is something that you can control. If you want to retry 20 times, 30 times, or whatever your number is. For the order data flow pipeline, we are just creating a flex template. So basically, whenever you want to create a data flow job, you create a flex template, you save that template into a GCP bucket, and you refer to that while creating the job. So we are creating a flex template. We are just putting the location of that template where it is located. We are saying that we want to deploy this job in this particular region, and we are giving the parameters out here which are required for that particular job. We're saying that you need to listen to this particular topic subscription, and this is the BigQuery table that you'll be creating the rows in or entries into. We are also defining what environment variables the data flow job requires. What's the temp location? What is the worker zone? So yeah, so pretty much it, like all the necessary parameters required by the data flow job, and the shipping params are just the same. Like these are the parameters required by the shipping data flow job. So you can just take this, go to the execution tab, paste this particular JSON, and you can change the call logs according to your requirement. If you want to see all the call logs, you can just change it to all calls and execute this. So if you see out here, it tells you what exactly it is executing, and you can check that in the logs as well. You can see out here like which step it is executing, what exactly is happening with your workflow. Everything is displayed out here. And if you go to the data flow, so you can see out here that it has triggered a data flow job for the order analytics and the shipping analytics. We'll just wait for the jobs to get started. Okay, so now you can see that the jobs are running. It's in the streaming mode. And now if you publish any messages to the pub subtopic, it should create a new entry into the BigQuery table. Now, the BigQuery table that I have, it already has a few entries. Like if you look at here, I have one entry out here and 2 or 3 entries into the shipping table. Now, if you publish any new messages, it will create a new entry out here. Let's go ahead and do that. Just putting some dummy messages out here. Change this to just publish this. If you can look at the table now, just refresh this. And we can see that there is a new entry out here. Similarly, in the order table, yeah, we can see that we have a new entry out here. Now this is simple. This is what the data flow job does. But if you kill these particular jobs out here, you will see that the workflow will create new jobs for you. So this is canceling. Now we'll just wait and watch for the workflow to create new jobs. Once these data flow jobs are cancelled. Yep. So if you look out here, it has created 2 new jobs for you for the order and shipping analytics. So if you have a requirement where you want to make sure that your data flow job keeps running no matter what, you can leverage GCP workflows to orchestrate it. Now, this is pretty much it that I wanted to showcase for today. You can find everything related to this particular topic into the blog post that I mentioned in the start. The links to the GitHub repositories and the input parameters required to trigger that particular workflow and to create the data flow jobs. Everything is mentioned in this particular blog post. Now, towards the end, I just wanted to highlight the cost you would incur in order to implement this particular design. If you know, you can also create a data flow job using Cloud Composer, which is also one of the recommended ways by Google Cloud Platform. But if your entire ETL logic lies into the data flow itself, there's no pre-processing or post-processing logic that is involved in your script, in your Cloud Composer script. GCP workflow can be a very nice alternative looking at the cost that you would incur by implementing a Cloud Composer. If you are having a Cloud Composer, this is the minimum cost that you would incur to create the Cloud Composer environment. Whereas if you're working with the workflow, the cost that you incur is related to the number of steps that you have in your workflow. And if you're having any internal calls or external calls. Now, monitoring a data flow job, creating a data flow job are all considered as internal calls. So let's say you have 30 steps in your workflow and you're having a similar requirement like the one that I just showcased. You want to make sure that your data flow jobs are up and running all the time. So let's say 30 steps are executed every 30 or 1 minute, 30 seconds or 1 minute. So you just do the math and you have about a couple of thousand steps that you execute in a month. So if you do that math and put that number out here, I think it would be approximately these many steps. If you do that, you would see that you're just spending 25 US dollars as compared to 391 US dollars. And this is the cost to have a data flow job in a streaming mode. But this is all based on the requirement, like how many worker nodes you require if you're having a streaming job or a batch job, and you can do the math. But in order to just orchestrate a data flow job, I think this is a very good alternative to Cloud Compose. Thanks for watching this video. If you like this video, please share, subscribe, and like the video so that more people can watch it. And thank you. See you next time.